Hey, good afternoon. This is Christopher Andrin with Chemir Analytical Services, which is a division of Evans Analytical Group. I appreciate your time this afternoon. I'm going to take up 15 minutes of your time and no more, as we promised back last month when Chemir provided a webinar through UL Prospector. We discussed some case studies involving plastics and polymers. And the webinar back a month ago included just abstracts, just 8 different case studies, just with some objectives, technical approach, and resolution. And so 8 very quick abstracts of case studies. And as promised, we're going to be offering several more detailed case studies for select case studies we discussed last month. And today we're going to be discussing multi-layer polymer film characterization. This is from a real project just showing the combination of analytical techniques applied at Chemir. And the UL Prospector webinar we provided last month highlighted case studies that we presented when Chemir was at NPE 2015 in Orlando back in March. And all these topics on the screen are what we presented during NPE 2015. And as I mentioned, today it's going to be a multi-layer film characterization project, just highlighting different analytical techniques that we applied to address a polymer film characterization project. And again, Chemir Analytical Services, a part of Evans Analytical Group. You guys have all saw the same slide a month ago, but just letting you know who we are. You saw this information a month ago, just all the different analytical techniques that we offer within EAG. And so again, we're a powerhouse of different types of analyses, different analytical approaches for characterization of different materials. And much of the work we do at Chemir and EAG deals with polymers. And you can see so many different polymers that we've got experience and expertise with characterization, analysis, investigating failures. And as promised, today it's going to be discussing a very detailed polymer film characterization project from a couple years back. And the again, the outline for this, or the approach, we'll be discussing the background. So the client that came to us, a client that was involved with research and development of a very specialized multi-layer polymer film. The film was being designed, as you can read there, to provide some very specific physical properties, physical integrity, barrier properties for gas, moisture, microbes, things like that. So a very, very engineered type of polymer film, different materials in the construction, different sequence of those materials, so a very involved polymer film. And the request that was made of us was more or less a quality check of some prototype film that they were producing. So they had their specs, their designs, what they wanted on their wish list in this polymer film, and they came to us to, again, assess the quality. Was the film that they're producing during R&D meeting what they're trying to produce? Some of the things we were investigating was confirmation of the polymer film for the number of different layers, the layer thicknesses, which was very key to the performance, the presence of some specific inorganic fillers and additives that gave the material some specific barrier properties, and even dispersion of some of the additives, which is very key when you're formulating a polymer. You want to have your additives well dispersed. So that's what was approached, what the client approached us with, this very, very challenging analytical task here. The different analytical techniques that we applied for this analysis, and this is just some of them. There's some other techniques I'm not going to highlight here. And again, I'm kind of giving you just the end result of everything that we did for characterization of this film. But the analytical approach we applied include sample preparation, a very key step in any type of analytical approach. Is how do you prepare the sample for analysis? In this case, we're doing some cross-sectional microtoming, and again, looking for exposure of those different layers. We use some scanning electron microscope, energy dispersive spectroscopy, Raman spectroscopy, even some ICP for quantitation of elements, and physical property testing, just to make sure that the material in its final form met certain physical property needs, tensile elongation, even peel strength. So this is just some of the analytical techniques that we applied for this characterization. And again, what I'm going to present here is just showing how a combination of analytical techniques in the right hands with the right experts can really give some powerful information on composition of a finished product. So layer thickness was very key. There was 5 main layers that they were investigating. And so through cross-sectional analysis and SEM measurements, we were measuring some of these different polymer films. We didn't know how thick things should have been. We didn't know how thin things should have been. This was pretty much a blind study. But as you can see here, you can see 4 very distinct polymer layers. And we analyzed multiple sample preparations just to look for uniformity in the polymer film. And this is just a representative SEM micrograph. But you can see 4 very distinct layers there. But there's also a very thick outer layer. It didn't need to be measured, but that was part of the construction. Is everything on the left-hand side of your screen was kind of like a substrate, a thicker polymer. Those other 4 polymer layers were really where the magic occurred. So objective number 1 was done. We confirmed the presence of the different layers. We measured their thicknesses. Another objective was looking for an inorganic additive dispersion package. And using SEM with EDS, we were looking at the outer layer. So we had an inorganic additive that was in the outer layer, that big, thick layer that was on the left side of the last screen. And so each of these little white points is actually specific to a given element that was present in the additive package. And so this SEM image here shows very good dispersion of the element that was incorporated into the polymer film. So again, every white dot is reflective of a single element. And again, we see very good dispersion, no clumping, no striations, so very, very, very good dispersion, again, using SEM. So again, another objective of what the client was looking for was met. Part of an SEM, you can interface it with EDS spectroscopy, which is looking for the elemental profile, detecting certain elements. So through other sample preparation, and again, analyzing this outer thick layer of this dispersed inorganic additive, just kind of confirming what was there with EDS, providing elemental profile, and this analysis confirmed copper. There's a copper additive that was, we didn't know it at the time. Like I said, this was a blind study, but our results showed the presence of copper as the only inorganic additive in this outer layer of the polymer film. So again, another objective met. Here is yet a different analytical technique, Raman spectroscopy, providing chemical fingerprinting of both organic and inorganic materials. And this was more, this exercise here, this technique was looking for another additive. The pink is showing the film matrix of one of the polymer layers. The blue, I'm not going to disclose what that is. It's not all that important, but that's a little proprietary, but it's okay to present it here. The green spectrum that you see here is indicative of a carbon sample, of a reference standard of carbon. So essentially what we're looking for in this pink, the matrix with no particles, no inorganic particles, was the presence of some carbon that was dispersed throughout the material as a uniform blend. And so this analytical technique was simply used to indicate elemental carbon, which was designed to be in one of the polymer layers. Again, just representing a different analytical technique, providing certain chemical information, a chemical fingerprint for elemental carbon. Now, we also used Raman spectroscopy in a different form, a little narrower of a window what we're investigating. Back to the outer layer where we saw copper, we're looking to speciate the type of copper that was present as the additive. And through Raman spectroscopy, getting a chemical fingerprint of a distinct region within the polymer film, we looked at given particles. Raman spectroscopy, very nifty. It can look down to micron-sized particles. And these were very small particles in this polymer film. But the blue spectrum we see is from a copper oxide. It's a reference material that was analyzed. And we confirmed that the red copper dispersed through the outer polymer film was also the same copper oxide, the same oxidation state of copper, which was key in the performance of this material. So again, Raman spectroscopy being used to characterize polymers, elemental carbon, in this case speciating the type of copper oxide that's present. So again, the right analytical tools in the right hands giving some very good information. And again, this is confirming the additive that was present, confirming dispersion of the additive that was designed to be in the polymer film. And so again, this is a very quick demonstration of using different analytical techniques for characterizing a polymer film. Some other techniques I mentioned up front, we did some ICP analysis, which quantifies elements. I didn't present it here. It's not all that interesting to see just a bunch of numbers, but we provided or performed ICP analysis to quantify carbon and came up with a level that was expected to be present. The earlier slide also mentioned some physical property analysis, and we measured tensile elongation, even peel strength of one of the layers, and generated those numbers as part of the report. Didn't know what numbers that they were expecting, but that was just part of what we had generated. And as far as the conclusions from this very detailed multi-layer polymer film analysis, we concluded, or actually helped confirm, of the 5 targeted compositional specifications that they had for this R&D product, they had already met 4 of them. And we had analyzed multiple specimens, again, looking for uniformity, compositional uniformity of the material. So 4 of their 5 targeted specifications were met. The one spec that they didn't meet, the data that we provided gave them the information they needed for an alternate material selection. So even bad news can be good news, because it allowed them to make the changes they needed, both for materials and process, to meet that last specification. One thing we didn't know during this analysis is that our results were we were requested to be a third-party testing, and we didn't know that up front. And everything that we generate, all of our results, matched their own internally generated data. They had their own analytical lab, and they confirmed everything that we did. This is pretty much the same numbers. A client of theirs that they were contracted for this R&D effort needed to have third-party verification of where they were at along the R&D process. So again, all of our results matched what they already saw, so that just aided them in giving the credibility to their client that they're on track for this specific material that they were developing. And if I'm not mistaken, I mean, that is our short, very defined case study on a single analytical project that we had here at Chemir in St. Louis. And again, just highlighting some of the different analytical techniques that are combined for this type of material characterization. So, and again, here is my contact information. Again, my name is Chris Andren, the Senior Technical Specialist with Chemir. My role with Chemir is providing project design. So I'm the person give a call. The last UL Prospector webinar, we had so many questions, not only during the seminar, but also some follow-up phone calls and emails. So again, please don't hesitate to give me a call. Again, my name is Chris Andren with Chemir. I appreciate your time, and we look forward to giving you some similar presentation. I believe 2 will be provided next week, 2 different case studies with a lot of this detailed analytical information. We're going to give 2 next week, and I believe 1 or 2 the following week. So we'll be emailing you that information shortly. All right, thank you. Bye-bye.